All right, we're going to do our last lesson over the radical stuff for now. This is rational exponents. So there's a few things that you need to know. The rules are up top. The rule is if it's a number raised to a power that is 1 over, like it has a fraction power, then that denominator n is the index of the radical. Okay? So if you have a number raised to a fractional exponent that's m over n, so maybe 2 over 3, 4 over 5, 7 over 6, then the denominator is still the index, and the numerator is the exponent on the number under the radical. I'm going to show you how to do all this, but that's going to be our main information, is the denominator is the index. Okay, the denominator is the index. If you can remember that, we're good. Then I gave you your exponent rules because those are still a little bit foggy for us. If I'm multiplying two bases together, then I add the exponents. If I have a power to a power, I multiply the exponents. If I have a division problem, I subtract the exponents. If I have an exponent that's negative, this may be new for you. If I have an exponent that's negative, then all I have to do is put that in a fraction, so put it in the denominator and it becomes positive. So we're going to apply all of that. Okay, so exponent rules, and the denominator is the index. So let's look at A. A says 64 to the 1/2 power. I'm looking, I've got a fraction exponent, and the denominator is the index. So when I draw my root, what is my index? 2. It's a square root. So do I have to put anything out here? No. Nope. So it's the square root of 64 raised to the first power, so it's just 64. So 64 to the 1/2 is the same thing as the square root of 64. They are identical. So I'm going to take 64, and guess what I'm doing? Breaking it down to the primes. So you should be able to do that pretty effectively for me. So if you'll take care of that. Should have gotten 6 2s because 64 is 8 times 8, and each of the 8s is 3 2s. So 64 is actually 2 times 2 times 2 times 2 times 2 times 2. 6 of them. Questions there? Are you okay with that? Okay, so now I'm looking for groups of 2. So I take out a group of 2's here, and I write it down. Then I'm going to take out another group of 2's, and what do? But I put a multiplication sign in between, right? And then another group of 2's, and write it down. So what is 2 times 2 times 2? 2 times 2 is 4 times 2 is 8. Sorry. So the square root of 64 is 8. And you're done. There was nothing else left under the radical. So 64 to the 1/2 power is 8. Questions? Let's look at the next one. I've got 11 to the 1/2 power times 11 to the 1/2 power. So if I were going to rewrite this as a radical, then what would 11 to the 1/2 power look like? Square root of 11, right? And then times 11 to the 1/2 is square root of 11. Now I've seen this. I've seen a square root times a square root, right?
Don't you put one negative? Or is that different?
Nope, don't even have to do that. So what is the square root of 11 times the square root of 11? What happens when you multiply a radical by itself? You get 11. Right? Okay, so that's done, but I want us to look at it with just the exponents, so that in case you need to do something with that. So I can do it like this. I can put it in radicals. I can multiply it and get an answer. Or I can take 11 to the 1/2 power times 11 to the 1/2 power. Now, based on my exponent rules, right up here, If I have something that's the same base, so my 11s are the same, what do I do with the exponents? I add them. That's all I'm going to do. So I'm going to take my 11, and I'm going to take the exponent of 1/2 and add it to the other exponent of 1/2. So 1/2 plus 1/2 is 1 whole. So this is actually 11 to the first power, which is 11. So either way, you can go either way. You can either handle it with radicals or handle it with exponents. Questions? Look at question C. It says 3 to the 1/2, so write it as a radical. 3 to the 1/2 is actually going to be square root of 3. Would you agree? And then 12 to the 1/2 is actually going to be square root of 12. I can't use just my exponents because my bases are different. So I'm going to go ahead and put it in radical form. And now what is the square root of 3 times the square root of 12? What's 3 times 12?
36.
So square root of 36. That's what I'm dealing with. Square root of 36. So what are you going to do now?
Prime.
Take it to the primes. You do it.
What's the name? What?
36. Once I get it into the primes, I know it's 2 times 2 times 3 times 3. So let's take out groups of 2. So I take out a group of 2s, so I pull out a 2. And then take out a group of 3s, so I pull out a 3. So 2 times 3 is 6. So the square root of 36 is 6. Or 3 to the 1/2 power times 12 to the 1/2 power is 6. So far, so good? Here we go. Let's go backwards now. I'm going to give you two expressions. One of them is w to the 5/8, and one of them is w to the 0.2. So we are going to write those in radical form. So let's start with w to the negative 5/8. Now, my first alarm is that that exponent is negative. So if the exponent is negative, I have a really quick fix. I see that this w is basically on the top of a fraction, right? This is over 1. So in order to make that exponent positive, I'm going to go 1 over, and I'm going to put that w to the 5/8 in the denominator. And it becomes positive the moment I do that. But I've got to remember that this is now 1 over w to the 5/8. Okay? So you can't forget it's a fraction. So now I want you to take this exponential, w to the 5/8, and I want to write it in radical form. So it's going to be 1 over something. Now, what is my index? 8. So this is the 8th root of w to the 5th. So when I have a fraction as an exponent, the denominator is the index. The numerator is what is attached to that number. Now I could go ahead and simplify this. That is 5 w's. Would you agree? 5 w's lined up, and I need groups of 8. So I could manipulate this and get rid of that radical, correct? But right now I want you to see what happens when you have a negative exponent, what you have to do to make it positive. Questions? Okay, let's do it again, except this time I have w to the 0.2. Well, first of all, I don't like that decimal. So can you please tell me the fraction for it?
1 over w.2.
I just want the fraction for 0.2. What is the actual fraction for 0.2?
1/2. Oh, wait, never mind. I'm dumb.
What is 0.2 as a fraction? 1/5. So I'm going to rewrite that because I know the rule if I got a fractional exponent, but I didn't know a rule if I had a decimal. So w to the 0.2 is actually equal to w to the 1/5. And you can put 0.2 in your calculator and do math enter, right, to get an actual fraction. So now let's rewrite this as an exponent. What is your index?
5.
So this is the 5th root of w to the 1st power. Y'all still okay? Let's keep going. Now what if I have the 4th root of x cubed? Let's just work with that one. The 4th root of x cubed. I want to write that as an exponential, so I want a exponent. So if I change this out of radical form into exponential form, my x is my base, but it's x to the what?
3rd.
What is my denominator? 4, and my numerator is 3. This is x to the 3/4 power. So let's do this other one. It says the 5th root of y, and all of that is being raised to the 4th. Be real careful. Take note of those parentheses. Those parentheses mean, okay, I'm going to deal with what's inside first, and then raise it to the 4th power. So I want you to first rewrite what's inside the parentheses as an exponential. So this is going to be y to the what? What is my exponent on my y?
1.
That's my numerator. My index is 5. That's my denominator. So it's actually y to the 1/5. But that is all being taken up to the 4th power because it's inside the parentheses and that 4th power is applying to it. Questions so far? So from the inside out, please work from the inside out. Now I've got a power to a power. Looking at your rules, if I have a power to a power, what do? This one is the power to a power. I'm going to multiply them. So I'm going to take 1/5 times 4, or you're going to take 1/5 times 4, and it's going to be y to the 4/5 power. And you're done. So we're going to have to kind of get used to going back and forth between these different forms, between radical and exponential. Questions so far? Okay, it's a matter of let's do some more problems. Sometimes you'll see it in science, like if you want to have rational exponents. So I want to expose you to a word problem, and that way you're not fearful. Planetary motion is Kepler's 3rd law of orbital motion. It shows you how to approximate the period P in Earth years that it takes a planet to complete one orbit around the sun. Use the function P is equal to D to the 3/2 power. So I've got that rational function, that rational exponent, where D is the distance from the planet to the sun in astronomical units, AUs, which is about 93 million miles, or the distance from Earth to the sun. And then we're going to ask ourselves, how many Earth years does it take? So here is the problem we're going to deal with. Still the same type of problem. I'm still dealing with P is equal to D to the 3/2, where P is the number of Earth years it takes. What is P? The number of Earth years it takes any other planet to orbit the sun, and D is the distance from the sun in astronomical units. So I want to know what a Venusian year if Venus is 0.72 astronomical units from the sun. I'm going to use P is equal to D to the 3/2. But now I got to know what is P and what is D, right? P is the number of Earth years, and D is the distance. Now, what do I have?
The distance.
I have the distance. So I'm plugging in 0.72 in for D. So P is going to be equal to 0.72 raised to the 3/2 power. But I don't want to use it like this. I want to go ahead and put it in radical form. So I'm going to rewrite this as, what's my root?
0.7.
No, my root. It's a square root. Square root of 0.72, and that is raised to the third power, because that's the numerator. Now, there is no reason why we should do this by hand, so grab your calculator. And I want you to put the square root of 0.72 cubed. Make sure that cube is underneath the radical, because you want to cube the 0.72 and then take the square root of that. Yes. 0.61 Earth years. That's how long it takes Venus to travel around the sun. So, no, not even a whole year, right? 0.61 Earth years. So not quite a full Earth year will be the time it takes Venus to travel around the sun, to orbit around the sun. So I want you to do it again using a Jovian year. And I'm going to pause. I want you to work it, and then we'll check it. So please make sure you check your B. It's 12.76 Earth years. Make any corrections necessary. And on to the next page. And here we go. I want to go ahead and solve some of these. So I've got the square root of 3 times the fourth root of 3. Now what I told you was you can't do this, didn't I? Because my indexes didn't match. But I'm going to change my mind now and tell you that you can. But I need to change these into exponentials. So change the square root of 3 into something with an exponent. So what will that look like? What is equivalent to the square root of 3? 3 to the 1/2. Correct?
Yes.
Times. What about the fourth root of 3? What is that going to look like?
The same, but in parentheses with the 4.
So 3 to the what power? 1/4. Right? Because the denominator is the index. Now, are my bases the same? Both of them are 3's, right? So if your bases are the same and you want to multiply them, what do you do with the exponents? Add them. So this is what I'm going to do. I'm going to take my 3 and I'm going to take my 1/2 plus my 1/4. Because anytime I multiply like bases, I just add the exponents. So this is 3 to the 3/4 power. Because 1/2 plus 1/4 is 3/4. Now, write this as a radical. Take it back. What's the index? 4th root of 3 cubed. Yep, you got it. Still okay? All right, let's look at B. So, square root of x cubed divided by the cube root of x squared. Again, I told you can't do that, right? Because the indexes were wrong. So, let's go ahead and rewrite it as exponentials. So, my numerator is going to be x to the, what's my numerator? 3. What's my denominator? 2. Because it's a square root. And then on the bottom, it's going to be x to the 2/3. The denominator is the index. What is the denominator? The index.
So you just pretty much flip it.
Okay, now that I have it in this form, I'm dividing, so what do I do with those exponents? Subtract. So when you're dividing things, you subtract the exponents. So it's going to be x raised to the 3/2 minus 2/3. We want to go ahead and subtract those exponents. So I'll give you a second. So 3 halves minus 2/3 is x to the 5/6, isn't it? Do you remember where to find your fraction? So this will be a kind of a good little lesson. So alpha and y equals, we'll pull up your fraction menu. I'm going to pick 1, which is numerator over denominator, so I'm going to hit number 1. And I can put 3 halves minus, do it again, alpha y equals, minus 2/3. And you get 5/6. So a couple extra keystrokes, but you can put in fractions pretty easily. So take this to the radical. X to the 5/6 is also 6th root of x to the 5th. Yep. Okay, I want you to do C. I'm going to pause and then we're going to check it. When you're done, make sure you check yours with mine and make sure you've gone all the way back to the radical form as well. So not rushing you at all. Go ahead and double check. Make any corrections, questions. Still okay?
I got it wrong the first time, but instead of a 7, I put a 3.
Oh, that's special. Okay.
Oh, that's what I put.
Okay, the last few problems, let's see if we can take care of them. Look at A. What do you notice? 32 to the negative 3/5 power. What's the first thing that catches your eye? It's negative. How do I make it positive? Make it a fraction, put it in the denominator. Do that now, because I got to remember this is 1 over 32 to the 3/5 power. Once I move it down there, it becomes a positive exponent again. Thank goodness. So once I have a positive exponent, I'm going to go ahead and now write it in radical form. You should be a step ahead of me. So we're going to write that in radical form. And check it. Questions. Now, this says 32 cubed. If I do 32 cubed, I'm going to get a really big number. But what I know is that I can take 32 and pretty quickly bust that down to the primes. So let's do that first. Take 32 all the way to the primes. So when I got a little crazy with the 2's. When I break down 32 into the primes, I get 5 2's. Would you agree? 2 times 2 times 2 times 2 times 2. Now, this says 32 cubed. So wouldn't it be smart of me to take 32 to the primes and then understand that I'm going to have 3 total groups of those 2's? Do you understand why that is? Because it's 32 cubed. So this is 32 times 32 times 32. So don't I really have 32 cubed in 2's right now? I do. I do. So I gotta make sure I understand that 32 cubed is just 32 times itself 3 times. So I could do it once and then just duplicate. Now, once I have that done, what am I looking for groups of? 5. So here's a group of 5 2's. So I'm going to pull that out. Here's another group of 5 2's. So I pull that out. And another group of 5 2's, right? Do I have anything left underneath? No, but what I have to remember is that this is 1 over that. So my fraction is 1 over, what is 2 times 2 times 2? Yes. Now, if you get a problem like this on ACT, are you going to take the time to bust this down to the primes? No, you're going to grab your calculator, and everyone's grabbing their calculator right now. And you are going to put in 32, and you are going to raise it to this negative fraction exponent, and here's what you're going to do. So once you're up top, yes? Go alpha y equals, and choose number 1. Now put in negative 3 over 5. Hit enter. What do you get? A decimal, right? Change it. What do you get? That's what we got. Right? Okay. Can't do that if you got variables in there, but we can do some checking. So put your calculator away. Let's do B. We're going to do it by hand because you got to know where it comes from. So rewrite this as a radical because it's not negative. Hallelujah. Not negative. Check your radical. What am I going to do with that 16? Please take 16 to the primes. And if I do that once, I can do it the other 2 times, right? Because I got 3 16s. So 2 times 2 times 2 times 2 is 16. But I have 16 cubed. So then I need 2 times 2 times 2 times 2 again, and then I need it one more time because it's 16 cubed. What am I looking for? Groups of 4. So here's a group. That's a 2. Here's another group. That's another 2. And another 2, which is equal to 8. So grab your calculator, check it. Let's make sure you're okay putting these things in. So I'm going to take 16 and raise it, and I got to do alpha y equals to put in a fraction. And do you get the right answer back out? Very good. Okay, questions? Let's see what you can do on C. So I'm going to pause. I will make you notice that it is a decimal, and I don't like that. And it's negative. I better deal with that. Okay? Okay, so on C, once you get it all set up, you get that negative exponent moved down, you get that negative decimal changed to a fraction, and then we write it as a radical. Here's where my brain starts trying to take shortcuts. I know I'm looking for groups of 2, and I know in every 9 there is a group of 2 3s. Would you agree? So how many 9s do I have that are broken down into 2 3s? I have 7 9s that are being broken down into 2 3s each. So that means I'm going to take a 3 out 7 times. So I take 3 to the 7th power, and that's 2187, or I draw it all out, and that's okay. And then I check it with my calculator. But I have to remember that the first thing I did was moved it to the bottom so that I would have a positive exponent, so it's got to be 1 over. Please, please, please don't forget your fractions. Okay, we've got one problem left because we're not going to do B. We're looking at A. I will tell you one thing already. It's negative exponent, right? So go ahead and switch it. 1 over. And we've got 8x to the 15th, and that is being raised to the 1/3 power. So that 1/3 power is applying to everything in those parentheses. So when I think about that, I got 1 over 8 to the 1/3 power, and then I've got x to the 15th to the 1/3 power. So I write it out separately so that I remember that 1/3 goes to each one of those terms. Okay? Now it's a matter of What is 8 to the 1/3 power? Well, this is 1 over. If I write 8 to the 1/3 power as a root, it's a cube root of 8. And then what happens when I have an exponent raised to another exponent? What do? Multiply. So I need to know, what is 15 times 1/3? It is x to the 5th. So I'm almost done. Because x to the 5th, like, that's done. So what is the cube root of 8? How many? Break 8 down into the primes. Yep, and you're looking for a group of 3. So what am I going to take out? A 2, and then you have your x to the 5th. So it's 1 over 2x to the 5th, and that one's done. Make sure you glue this in. We will have Pearson 9-4 to go along with it.